So in this context, these kind of critical lice loadings are really effectively thresholds of as Susie's just been talking about. And these are basically points at which, beyond which you would expect particular either physiological responses or in some cases mortality. And this diagram here is really just to demonstrate our thinking behind this. So with increasing lice per gram, we expect these effects to become more severe. So this kind of bottom line here, this below this point, we assume the effects to be broadly kind of superficial and localized to the area of feeding. And above this line, so kind of in this area here, the effects become more systemic, kind of affect the fish's kind of overall health and welfare. And this kind of upper line is really the point beyond which we expect mortality to become a much more severe problem. So to determine these thresholds, we used a mixture of a meta-analysis and a review of the existing literature. For the sublethal threshold, we used a direct qualitative assessment, so using a range of published studies where we could extract lice per gram values and associate them with particular physiological impacts, and we then catalog these to kind of assess what kind of impacts they were. For the mortality threshold, we actually used a data set that we were able to collate from a number of different studies to basically perform a logistic dose response analysis, which allowed us to then calculate kind of a point where we would expect roughly kind of the probability of mortality to exceed around 50%. So here, this is the table looking at sublethal impacts. So this kind of area highlighted here in blue is the kind of the lowest end of the lice. So we're looking at, again, all the impacts seem to be predominantly skin related and kind of reasonably localized. But as we increase, the number of lice increase, so around 0.08 lice per gram, we start to see more kind of severe sublethal impacts. So these kind of impacts, so reductions in cardiac output, hematocrit, so red blood cell count is down, and decreases in the ability of swimming performance, so up to around 20%. And obviously, there's also some increases in stress response as well. And these can have a wide range of potential impacts to kind of, particularly to wild fish. So obviously, reductions in endurance and loss of swimming speed will make them more vulnerable to predation, and also excuse me, lead to a longer period of time taken to kind of exit the kind of the coastal fjordic systems that they need to migrate through in so many countries. Moving on to the mortality threshold. So this graph is looking at the dose response analysis. Really, the take home here is this kind of vertical line, which represents this kind of 50% probability of mortality occurrence. And from our calculations, based on this kind of data set of collated data, it sits at around 0.24 lice per gram, which broadly is quite consistent with what was already used previously and also what Susie has just been talking about as well. So in conclusion, these kind of thresholds are an integral component of aquaculture management and are currently used in, obviously, a number of management systems, but also can also be developed into kind of modeling frameworks. But what we're proposing here is looking at using a more holistic approach to setting these thresholds, so trying to take more account of wider ecological impacts of lice and how they impact fish even prior to them causing direct mortality. A sublethal welfare threshold that we've talked about sits at around 0.08 to 0.1, roughly, with the kind of mortality threshold where it becomes more probable, sits at around 0.24 lice per gram. And that's everything for me. Thank you.